This is example problem 2.2, and we'll be going over the intermediate value theorem and its impacts. It asks us to prove that for the function f of x equals cosine x minus x squared on the interval from 0 to pi over 2. Use the right type of brackets. Use the intermediate value theorem to show that a root exists. So in this case, a root means just a zero crossing of the function. It's basically, think about roots of a second order system, and you're trying to find where the functional system balances. So in this case, we just really need to solve the problem. I have to just plug in 0. So cosine of 0 is, of course, 1 minus 0 squared. Okay, so f at 0 equals 1. That's one side of our domain. That's the 0 plug-in. So let's do the pi over 2. So cosine of pi over 2, so that'd be equivalently 90 degrees, putting it in degrees. So that would be function, let's write this out the right way, pi over 2 equals cosine of pi over 2, that'd be 0 minus pi over 2 squared. So that would, 2 squared is 4. So this tells us what we need to know. That at the left side of the domain, if we draw this out on a number line, when we plugged in a value of 0, we obtain the output value, functional value of 1. When we're on the right-hand side of the domain, namely pi over 2, then we received a negative functional value, negative pi squared over 4. So I shouldn't draw that x there on the line. That's misleading. It's actually down here somewhere. So somehow the function between these two intervals, who knows the path, you can plot it if you want to real quick in MATLAB, crosses the 0 boundary, and that's where you obtain your root. That's all there is to problem 2.2. The intermediate value theorem is exactly as easy as you might hope, and it's exactly as easy as it sounds.